Here goes a video on exponential growth. So to start warming up our brains, let's sketch a graph of y equals 2x, y equals 1/2 x, and y equals x squared. So 2x, as you know, starts at the origin, and it just increases at a rate of 2 over 1. 1/2 still starts at the origin, but this time it raises at a rate of 1 over 2. And x squared is just where we square numbers, and we're going to get a parabola. Well, exponential graphs are a little bit different. So an exponential function we can think about as like a sheet of paper. So take a sheet of paper. And then what's going to happen is you're going to fold it. And if you have one fold, how many layers of paper do you actually have? Well, if you think about it, the answer would be 2, because you'd have one fold, but you'd have 2 pieces stacked on top of each other at the fold. And then if you were to fold it again, it becomes 4. And then if you were to fold it again, it would double to 8. If you folded it again, you would have 16. It's just going to keep on doubling every time. So the function can be modeled y equals 2 to the x power. So that means if you have 0 folds, you are at 0, 1. But once you have 1 fold, you're at 2. When you have 2 folds, it went up to 4. And then when you had 3 folds, you went all the way up to 8 layers. So it's not really like x squared in a way. It's different, because then your next fold would have brought you all the way up to like 16. But then what if you were going in a negative direction? Again, another reason why it's not like x squared. If it was x squared, negative 1 squared is a positive 1. Or negative 2x squared is a, positive 4 once you square it. Well, what if you went to a 1/2? That's like taking a laser and shaving that slice of paper in half, because 1/2 power is a reciprocal, so 2 to the negative 1 would be 1 over 2. So an exponential graph is going to look like this, where it's going to get closer and closer to the x-axis as it goes to negative infinity, but you just keep on multiplying by 2 as you go to the positive direction. So that is what an exponential function looks like. So when we get into some real-world scenario exponential functions, what you need to do is look at 3 pieces. You have A, which is your initial amount. You have your R, which is your rate, and usually that's going to be a percent. Increase or decrease for exponential growth, it's going to be an increase. Tomorrow or in our next video, we will talk about decrease. And then T is time. Now, a lot of times it's in years, but sometimes it can be in days, sometimes it can be in hours, so you must make sure that you read the question carefully. Okay? So, there is a pond stocked with 200 fish, and the Department of Wildlife expects the population to increase at a rate of 5% each year. How many fish will there be in the pond after the first year, 2 years, 3 years? So you just have to use your equation where you are going to use the initial amount of 200 fish, and then that's going to be times 1 plus your rate of 5%. And 5% is 0.05, and then that's just going to be raised to the first year. So what you need to do with that is you just need to use your graphing calculator, and you're just going to type 200 times 1.05 raised to the first power, and that's just going to give you, after the first year, 210 fish. So that makes sense. 5% of 200 is 10 fish. So 200 plus 10 more fish is 210. But what happens when you get to 2 years? When you get to 2 years, that's going to be 200 fish, still times the 1.05, but this time we're going to raise it to the second power, which is not going to be 220. If you type it in the graphing calculator, it's going to give you 220.5 fish. And that's because the formula works in a different kind of way. Last example, 3 years. That would be 200 fish for the original times 1.05 for your 5% growth raised to the third power. And that would give you 231.52 fish. Now, of course, I know you can't have 0.5 fish. You can't have 0.52 fish. But this is just how the formula works. And the reason why is to give you an example. Why does the formula work? You are not adding 10 fish every time because you're doing 200 fish, and then you're going to multiply that by 1.05 to the first time, and that's going to give you 210, and then you're going to multiply that by the 1.05, which is what gave you the 220.5, and then again you're going to raise that to the 1.05 to get your 231.52. It doesn't just add 10 fish every year. It takes 5% of the previous year's amount of fish and adds that to it. Okay, so this is why we have 200 to the first power. That's what happens once it's squared. This is what happens once it's cubed. All right, so that's how the formula works. It also works in a way like that for compound interest at a bank. So your money, if you invest it into savings, will grow. Now, the interest rates are not nearly as high as they are in this, shall we say, note sheet. But back in the day, interest rates were pretty decent, and these numbers will kind of help you, get used to these formulas. So how does this formula work? A is your amount of money in the bank. That's your total amount of money. P is your principal, which is your initial amount of money in the bank. N represents the number of times it's compounded. T again is time, and R is still your rate. So to use this formula, you're going to need a calculator. And we're going to pretend that we deposit $2,000 that pays 6% annual interest, and we're going to find the balance after 3 years. But what we're going to do is we're going to change the number of times it's compounded every year. So annually means it's 1 time per year. Quarterly means 4 times per year. Monthly, obviously, 12 times per year. And daily is 365 days per year unless it's a leap year. So annually, the formula would look like this. 2,000 times 1 plus your rate of 6% over the 1 time it's being compounded this year, raised to the NT, which is 1 time this year for a total of 3 years. So in your calculator, you are going to need to type that in very, very carefully. So it would look something like this. 2,000 times 1 plus 0.06 over 1 is 0.06 raised to the third power. And that's going to give you, after 3 years, $2,382.03. So if you can find a bank that has an interest rate of 6%, that would be amazing for your bank account. But what's going to happen if it's quarterly? Well, you still set it up the same way, except for the only difference is once you get to the end position, you're going to put a 4 because it's going to happen 4 times per year. So now this time in your calculator, you need to type 2,000 times 1 plus, now you need a new set of parentheses for your 0.06 divided by 4. Close your parentheses and make sure you close your parentheses again. But now you're raising it to the 4 times 3, which is the 12th power. And then type it in your calculator and you're going to get, this time, $2,391.24. So as you can see, it's more if you do it 4 times a year than once a year. Once a year says that at the end of the year, hey, we're going to just give you 6% annual interest. Quarterly says that every 3 months they're going to give you interest. So then you'll build upon that interest, which means you'll build upon that interest. Okay? So what I would like you to do is pause the video and you find monthly, which means your N is 12, and daily, which means your N is 365. All right, pause the video, give it a try. So here you go. Monthly, meaning 12 times per year. Every month, you compound your interest, and you have $2,393.36. And if you do it daily, it'll be $2,394.40. So as you can see, the more something is compounded, the more money you are going to have at the end of the year when it comes to money in a bank. Now, we're going to even talk about something else where it does it continuously, like every second. But that has a different formula, which we'll talk about in the next couple of videos. So last question of the notes is, you want $5,000 3 years from now in an account that pays 3% interest compounded quarterly. How much do you need to invest? Well, this is just an algebra problem where you start with an equation where you want $5,000 at the end. So 5,000 is your your total amount of money in the bank. What we don't know is the principal value, how much you want to start out with. And then, of course, we have our 1 plus our 3% over compounded quarterly, so every 3 months or 4 times a year, raised to the 4 times for our compounded for 3 years. So now from this, you're just going to have to solve an equation. So 5,000 is equal to P times whatever we do when we type this in our calculator. So we're going to get something like 1.093806, yada, yada, yada. And it's just going to keep on going with your calculator. So you actually need to use that answer. Don't try to type it in. So now you just do 5,000 in your calculator, divided by, and then remember that second and then the negative sign button on your calculator will bring up the previous answer. So in the calculator, it's going to look like this: 5,000 divided by ants, and then you click enter, and it's going to give you $4,571.19. So if you found a bank that paid 3% interest, compounded quarterly, you would need to invest this much money to make, just over $400 at the end of 3 years. That's not bad for just sitting around and doing nothing. All right, well, that is exponential growth. The next video we'll talk about exponential decay, and then we'll start getting into something fancier called E. So this is Longo, and I'm out. See you, bye.